Hi my friends, today we model this part. You see it has some interesting features and the drawing is this one. We start by creating this contour. I don't present the dimensions, they are all here. Let's start. Standard millimeter SciPT, new sketch, XY plane, and we draw two lines. One, restart, two. They are placed with their centers on the same vertical with the center point. Dimensions are great. 212 is this, and 388 is the other. The distance between them is 462. Wow! What a big object. We don't used to work with such big models. The distance to the center point is 212. Good. Then we draw some lines. 1, 2. Press the left button and go here, then down. I connect this point with this point. I apply tangent here. I place this point in the center point. This is very important. 20 is this dimension. The last dimension we need 20, not 10. Fully constrained sketch. We draw a line between these 2 points and we apply mirror of all these 4 entities about this line or this axis. It is construction. Again, fully constrained sketch, of course. Let me move some dimensions here to be nice. I like to have nice drawings. I work a lot to create drawings, my friends. The extrusion is 220 minus twice 4, but this is here 212. Finish sketch, extrude, symmetrical, 212. Okay. Next is this feature, a circle. Dimension is 340 and the distance is 4. Okay, we select the midplane XY plane, F7, and we create that circle of 340 as a diameter, 340. Finish sketch, extrude, symmetrical on 220. Okay, you see it goes also here in the back. Then we have to create this empty volumes. We have dimensions here and we use them. The plane is also XY, F7, and we draw a full circle with a radius of 176. Another entity is an arc with center, starting from somewhere here, going to here. The radius is 190. Then we draw a line from a point down, left, down. We project this line and we cut this. Another line is from this end vertical to the bottom line. Dimensions, this is 14. Trim this extension. Another dimension is here, but let me create a symmetry by using a line between these 2 points and applying mirror of all these entities about this line. Apply. Done. This is a construction line. Then we place dimension here of 30. Another dimension of 144. And fillets of 10 millimeters between this arc and this arc. Also here, here, all these almost all these corners. One dimension needed. Let me see what is that dimension. I don't know. Let's see what is it. Oh, this. Control Z. I want to place by myself this dimension of 20. Then we project these two sloped lines and we keep the left button pressed to obtain this tangent. We hover on this projected line and we have a parallel. Then we go here, horizontal and tangent again to the circle. We apply manually this parallel and we apply a dimension of 20 plus 10. 20 plus 10. These dimensions are in the drawing. Trim this arc. We have a fully constrained sketch and we have to apply extrude. Let's see what is the dimension of this extrusion. 220 minus twice 18. Extrude this area, and this. Symmetrical with cut on 220 minus 18 twice. Okay. You see the result here. If we take a look at the part, we see this feature around the part. We have dimensions here. 220 is this and 388 is the other dimension. We have to observe that 4 millimeters is the difference between the two on each side. This is 220, this is 212, and this distance is 4 millimeters. Yes, also on the other direction, 220 minus twice of 4 millimeters. 4 is present in the drawing. We turn back that part, we select a face for a new sketch, we project all this area and we apply offset of this on 4 millimeters. Finish sketch, extrude, we select only this, not symmetrical but with join in the other direction on 20. Okay. Another feature is a big hole, diameter of 260 through the part. We use the tool hole. You see the diameter of 260 this is the face, this is the center, and all the way through the part is that hole. You see? Another hole is this one with dimensions 180, 168, 20 and 10. 10 is not useful because we already placed this face. Good. Let's apply this new hole. We select the face. We have this point, the center point, and we apply hole with the counter bore and dimensions 168. Here is 20 and the hole is this is 180 and this is 168, but not through all the part. I select this and I select to what? To this face. You see? Okay. Now this contour to be applied on this sloped face. Dimensions are here. You see, 3 millimeters from the edge, from this edge, this, yes, 3 millimeters aligned with the center, and a square of 162. Then fillet of 30, and the thickness is also 4 millimeters because this is 18, this is 14. You can verify. This means that this is 4 millimeters. You see here that dimension. Good. We select that face. We draw a rectangle with dimensions 162. Then we apply equal because this is a square. We move this to another position. We use the constraint vertical to place this aligned with this point. This is construction. Dimension of 3 from that edge. 3. Finish sketch. Extrude. 4. Okay. Now I measure with M by using the key from the keyboard, M from Monaco, and I measure this line. This is 396. Yes, and if we take a look here, we see 388 is this dimension, and we added other 4 millimeters around. I have to place 380, my friends, at the first sketch. Double click on the first sketch, and this dimension is 380. This is the possibility with parametric software. Yes, you can modify dimensions, not like in AutoCAD, where this is not possible. Good. We continue with the fillets of this edge. 30 is the radius, and we go to each corner for this. Oh, I keep press the shift button and I unselect that edge. I want to select this edge and this edge. Okay, then we have to apply this internal cut. Dimension is here, 16. 16 is all around the contour. Good. This is the face. We use it for a new sketch. We project this area and we apply 16 on offset. 16. Finish sketch. Extrude this area with cut to this face. Okay, we don't want to go through the whole part. Okay, now this 1, 2, 3 features must be mirrored. 1, 2, 3 features about this plane. Okay. Another extrusion is this one. Dimensions are here. 4 millimeters, 70 on 111 is the rectangle. The thickness is also 4 millimeters. We use this face. We draw a rectangle with dimensions of 111 tab on 70. 4 millimeters from the top, centered on the center point with this midpoint, on vertical, fully constrained sketch, extrude on 4 millimeters. Okay, this must be also mirrored. The last feature about XY plane. Okay, we continue with this 4 bosses. Dimensions: radius 15, 252, 280, and holes of 16. Good. We use this plane for a new sketch. We project geometry, this line at 4 millimeters, as you know. Then we draw a line up, go here, here, and this is closed. Radius 15. Distance from the center is 252 divided by 2. 252 divided by 2. And this is also half of 280. 280 divided by 2. Okay, now we apply extrude. Of this sketch ended on this line, but the other direction, with join on 30. Okay, we apply the whole of 16, not counterbore, not ending, but with a diameter of 15. Where to be placed? On this face and this center. Okay. Now we apply mirror of these two features about this plane. Okay. Mirror once again of the both mirrored entities about the plane XY. Okay. Another small feature is this connecting that two features. Dimension is 30. We select this face, F7. We create a rectangle with this dimension of 30. We project this circle and we place one corner on the circle. Then on the same vertical must be this center line. We also project this line to make identical or collinear this line with this line. Then we apply extrude of this area to this face. Oh, that circle is not well selected. Cancel. I go back to the sketch and I eliminate this circle. I project the other one, F7, and again connect this point with the circle. Once again, extrude this area to this face. Okay. Then we apply this hole, metric 12 on 15 through the part. We turn back the part, we select the face, we create this point, and we apply a new hole with threaded area of metric 12 and on a distance this is 15. The thread is 15 and it is through the part because we don't have any problem by selecting this point. See? Okay, this is the hole. Another hole is this one, perpendicular on this, the same 15, the same metric 12, but ending here and not through. The position is at 27. Okay, we select this face, we place here a point, we place the point on the same vertical with the center point, and we apply a dimension here of 27. Finish sketch, hole. All the data are the same, but not through all to this hole. You see? Okay. Now we can see that hole coming here and stop in this other hole. Now we apply these 4 holes on a diameter of 224 and the dimension is metric 16 with 22 depth. You see here 45. Good. I select this face, I draw a line with a length of 112, which is half of 224 divided by 2, tab 45. Finish sketch, hole, this is the placement, and 16 is okay, 22 is okay. Good. Okay. Then we apply circular pattern of this last feature about this axis 4 times, 4 instances. Now we place these holes. You see distance is 64 on 64 and the placement is 146. Since this is a square, on the other direction is also 146. The holes are metric 10 with 15 depth. Okay, let's work, my friends. I select this face for a new sketch. I draw a vertical line of 64 here. 64. Then I project this line because I place this midpoint aligned with this midpoint. The distance to the center point or projection of the center point is 146 divided by 2. I place points to have the holes instantly. Hole, and now you see metric 10, depth 15. Very good, it is already here. Then I make something interesting. I create a plane based on this face and this face to apply mirror of the two holes above this plane. Okay, then I hide the plane and I apply the same scheme with these two other faces. I select what I was made before and I use this plane. Okay, I hide the plane and everything is okay, no going through, no nothing. Then I mirror once again everything about these 8 holes about this plane. Okay, very good. Other 2 holes are these 2. They are threaded and they go through all the part, my friends, as well as these other ones. I can place a hole directly through the whole part for these 2 and also for these 8 holes. In the drawing we have dimensions. This is twice of 8 metric 6 on both faces and twice metric 12 here also on both faces. Let's start with this one. This is the face. We draw a horizontal line with the length of 63 placed at 36 from the upper line, 36, and centered on vertical with the center point. Okay, then hole 1, 2, full depth through all the part, metric 12, the 2 holes, they go through the part, so we have threaded on both sides. Now the holes on this face. They are placed on a circle with a diameter of 300, metric 6, 8 instances. We select the face, we draw a horizontal with a length of 300 divided by 2, finish sketch, hole, metric 16, through the part. This is the point. Okay, this hole goes through both ends. Then circular pattern for the last feature about this center, 8 instances. Okay. Now I see that these holes, 4 or 16, are wrong placed by me. Let me see where is that hole. This, you see, this is 15, it must be 16. I apply 16. Okay, now let's see what is the volume. Properties, physical, update, copy, close, drawing, double click, and the new value is almost the same. You see there is a small difference at the 6th rank of dimensions. This is nothing, but I keep this value because this is what we did here. Okay, the material is steel cast, the aspect is steel cast. We don't want to see edges. We change this on default lights, and we select faces to be machined. Also this. Okay, they are still polished. That's all for today. Thanks for watching. Bye bye.